All right, kiddo, let's talk about graphing. So there are two basic graphs that you learned. There was a sine function, which looked a little something like this. And there was a cosine function that looked a little bit something like that. Okay, so in your sine function, essentially what this is doing to an original sine graph is it's shifting it in some directions. This negative means it's reflected over your x-axis. This minus 2 pi means it's being shifted to the right 2 pi, and this minus 1 means it's being shifted down 1 unit. And each one of these things can be found based on this graph. So the period is what is the difference between the first and last points in between? Like, what is almost that width? And the way you figure out the width is you do 2 pi, so your period is equal to 2 pi over whatever the value is in front of that x. We call that b. And because our b value in this case is just the number 1, our period is equal to 2 pi over 1, or just 2 pi. The amplitude is whatever number exists inside of here, but the absolute value of that number. So it's really just 1 in this case. It's the highest height that our function is going to hit. And then our vertical shift is how you're moving it. So this is going down by 1. And our phase shift is moving to the right 2 pi. So when we go to graph it, here's our 0 value. I'm shifting over 2 pi. Now, the key bit to notice is that a sine function is graphed in 4 intervals. And this should make sense. It's almost like the unit circle. It's the sine values are going up. They are positive in quadrant 1, they're positive in quadrant 2, and then they are negative in quadrant 3, and they continue to be negative in quadrant 4, and then it keeps looping back around. So in this case, because it exists in 4 intervals, what I want to do is I want to figure out what is the length of each one of those intervals, and we call that a quarter period. So I'm going to take my quarter period, which is 2 pi. I'm going to divide it by 4. That gives me pi over 2. And that's what I'm going to go up by on my graph. So we have pi over 2. If I add pi over 2 to that, that gives me pi. If I add pi over 2 to that, that gives me 3 pi over 2, 2 pi. And then this is going to be 5 pi over 2. And then this is 3 pi, and this is 7 pi over 2, and then we have 4 pi. All right, so now remember what's happening here. I'm phase shifting to the right 2 pi, always opposite of what you see in the parentheses, and then I'm going to a height of 1. Ooh, Miss Crisco, what are you doing? I have to include the fact that my function is being shifted down 1 unit. So we change our midline. Sorry about that. Kyle, sorry. We change our midline. We shift it down 1 unit, and then I actually begin my procedure. And because of the fact that this function is negative, instead of moving up first, I'm actually going to move down. So it's a negative sine wave. And this is what your function should look like. All right. In this case, just take a look. This is 4 pi, so 2 pi over b. Try that one out and see how you do with it. All right, Kyle.